Hi, welcome back to Chem with Chem. In this session, we're going to be working question 3 of chemistry paper 2 from the January 2019 sitting. If this is your first time to the channel, then welcome. Please check out all the materials that are here that are posted for you. Be sure to share with your friends, like if you find value, and consider subscribing and turning on post notifications so you'll be notified the moment new content is added. Let's begin. Now, this question is an organic chemistry question, and it's on polymers and reactions of organic compounds. Part A. Polymerization is an important industrial process used in the manufacturing of many useful materials. 1. Define the term polymer. And this is something we would have seen before. A polymer is the compound formed when many monomer units join. Distinguish between Part 2, distinguish between addition polymerization and condensation polymerization. So in addition polymerization, when the monomer units join, the final product is 1. We get one continuous chain, whereas in condensation polymerization, when the monomer units join, we get the long chain compound, the polymer, and there's normally the elimination of a small molecule such as water or HCl. Part B. Figure 2 illustrates the formation of a polymer. Part 1. State the type of polymerization represented in figure 2. So let's look at the figure. Let's examine the figure and see what the repeating unit is. So our repeating unit is, we're given the repeating units. We have what looks to be a diacid compound on our left here with two COOH group, which is the functional group for carboxylic acid. So this is a diacid. And the other compound appears to be a diamine. We have two NH2 groups, which is the amine group on either side. So if we, well, no if, no buts. Whenever we have a diacid and a diamine reacting, we're going to get a condensation polymerization. We're going to actually get a polyamide, but we don't want to over answer part 1. We just want to state the type of polymerization. So the polymerization here is condensation. And they want us to give an explanation for our choice. And it goes back to our definition or our differentiation between addition and condensation. Earlier on, we had the elimination of water. And whenever we see elimination of water, it means that condensation, polymerization would have taken place. That's the whole point. Condensation having to do with the formation of water. So we can say water molecules were eliminated. So it's a condensation reaction or condensation, polymerization. All right, and it's just 1 mark. We don't need to over answer. C, identify one use of each of the following types of polymers. Polyester. So polyester is used to make fabric. That is used in clothing. Polyalkene, there are so many uses. We use them to make plastic containers. Plastic containers, buckets, PVC pipes, and so on. Part D, figure 3 shows the fully displayed structural formulae of compounds A and B. And we just want to look at compound A. We're seeing the OH group, functional group, the OH group there. In compound B, we're seeing the C double bond OH group. That's the carboxylic functional group. And they want us to, in part 1, state the homologous series to which compounds A and B belong. So whenever we see OH, we can just say O, and we know that we're talking about the alcohols. So compound A would belong to the alcohols, and compound B, whenever we see COOH, it means we're talking about our carboxylic acid, or what we call our alkanoic acids. And they want us to go a little further and to give the name of compound A. So we have 2 carbons present here. So the prefix we're going to use is eth for 2, and we'll add the suffix or the ending name anal. So this is ethanol. And just like that, 3 marks. Part 3, compounds A and B react to form compound C. Sketch the fully displayed structural formula for compound C. So let us just remind ourselves of what compound A is. So this is our structural formula for compound A. So we don't have to scroll up. So this is compound A, and we said that that was ethanol. Then we have compound B. So this is compound B, and both of them are going to react now to give us compound C. So B, we said, is an acid, a carboxylic acid, and A is an alcohol. Now, when alcohols and carboxylic acids react, we end up with what we call an ester being formed. But there's a when we're drawing the product, the ester, we have to draw the acid portion first. So let's just look at how the joining take place, or how the reaction takes place. I'm going to use black to show that it's the OH. We have to line up the OH from the acid with the H from the alcohol. And that will come off, that will be eliminated as water. And then in the middle now, we're going to get our C double bond O with a bond, which is the ester linkage. So let us now write the final product. We're going to start here on the left, starting with the acid. So we're going to draw CH3, that's the first portion, CH3. Let's put on the hydrogens as we go along. Then there's a CH2. Then we're going to have the C double bond O. And then after the C double bond O, the OH would have been removed, and this part here is going to be joined with the O up here. So we're going to have C double bond O, then we're going to have an O. And this is where the blue comes in, because We're now in the alcohol territory. So this is where we are now. So that's the O. Then we'll have CH2. And then the last part of the alcohol will have a CH3. They asked us to draw it. They didn't ask us to name it. But for practice, we could name it. We always name the alcohol part first. So we draw the acid part first, but we name the acid part last. So we'd name the alcohol part first, and we'd name the acid part last. So just for practice, this is, the name would be ethyl. Okay, let's be consistent with our colors. So this would be ethyl, and the acid portion would be propanoate, coming from 3 carbons. Propanoate, ethyl propanoate. Check. We answered part 4 a while ago in saying what compound A and compound B reacted to form. So it's an ester. And we said these are responsible for the lovely fragrance that we get in flowers. So it belongs to the esters. And they said that we should state 2 other types of reactions that compound A can undergo. So compound A, just a reminder, compound A was ethanol. So ethanol reacts, or alcohols on a whole react with organic acids to give us esters, right? So there are other reactions that alcohols can undergo. They can undergo combustion reaction, where they burn to give us heat, carbon dioxide, and water. And they can also undergo dehydration. So we can dehydrate our alcohols to get the corresponding alkenes. And just like that, we would have gotten 15 marks. So I hope you're putting in the practice and you're seeing the patterns. All right, so thank you again for joining Chem with Chem. Please remember to check out the other videos, like if you find value, share, and also consider subscribing and turning on post notifications so you don't miss each time new content is added. Couple later.